Hello guys, welcome to KDU channel. In this video, we're going to see about an electronic component which changed the world. I mean, almost every electronic component is a game changer, like transistor, capacitor, but this thing is strange and it has a simple principle but changed the world. Why I'm saying it is a game changer because it lights up the world and gave us a new type of renewable energy instead of using dynamos, and it is also a non-polluting renewable energy. And it is almost used in every project, like professional projects and DIY projects. It is used in every projects. So predictably, we're going to see about diodes. In this video, we're going to discuss about the principle of diodes and why it is a game changer. Now, let's start the video. Okay, simply if we connect the diode in your circuit, it only allows the current to flow in one direction. So if the diode allows the electron to pass through it, then it is called forward bias. If you change the current flow, it doesn't allow at all. So this is the basic work of diodes. In olden days, they used diode as a vacuum tubes, but that's old. Now almost every diode is made up of semiconductor. In this video also we're going to see the diodes which is work in semiconductors. Okay, first we have to know what is covalent bond. Simply imagine that there are two atoms, each has 5 electrons in their outer shell, so that they can easily join because both has 5 electrons, so they can share the electron with each other to join together. So this is a simple way to explain the covalent bond. Okay, semiconductor plays a main role in diodes, right? Okay, now let's see how semiconductor works in diodes. Okay. The most of diodes which we use for our project is made from a famous semiconductor and my favorite semiconductor, silicon. So this is silicon atom and it has 4 electrons. But the thing is, you can't see the silicon atom this much big and with this beautiful orbit of electron. So just imagine it is a silicon atom. So silicon atom can join with another silicon atom like this. We already discussed about it, and this is called covalent bond. We don't know how the covalent bond looks like in real life. For that we have to shrink in atomic scale, but unfortunately we can't do that. So just imagine like this. And this 2 silicon atom will join to another and another and another and goes on. Okay, now we're going to make a trick with silicon. Okay, the trick is now we're going to add phosphorus atom that is next to the silicon atom in periodic table, but the thing is, it has one extra electron. This makes the electron to move freely. If you make more pair like this, then more electron can move all over the place. Why this extra electron are moving all over the place? Because they can fill in the atom which has less electron to balance it, right? For example, take your battery. There are 2 terminals, negative and positive, right? Why are saying there's a 2 terminals? Because in negative terminal there will be more electron will be available. But in positive is not, comparing with the negative. So the negative electron will goes to the positive area because there is less electron. But here there is no place to fill the electron because there is only silicon atoms and phosphorus atom, right? So it's just roaming all over the place. Now we can easily say this area as a N type. N means negative because there are more electrons are there in this area. So we can say this is as a negative type. Okay, successfully we got N type. Now predictably we want P type, I mean positive type. For that I'm going to add aluminum atom instead of phosphorus atom. Because aluminum atom want less electron comparing with the phosphorus atom. Okay, this aluminum atom has one less electron comparing with the silicon atom. But in phosphorus there is one extra electron there. So it roams all over the place in that area. But here there is one hole. Hole represents to a lack of electron in that area. So this is the hole. So due to the hole, the other silicon atoms electron try to fill that hole. But again the hole is created in that area, so the hole is constant. Okay, now we know that this area has less electron comparing to the negative type. So this area automatically named as positive type or P type. Okay, we got N type and P type. N type has more electron because we are adding phosphorus atom with the silicon atom, and the phosphorus atom has one extra electron comparing with the silicon atom. But in P type we are adding aluminum. It has one less electron comparing with the silicon atom. So that's make a hole. Hole determines to a lack of electron in that area. So this area refers as P type because it has less electron comparing with the N type. And another thing will be happen in the diodes is called depletion zone. Okay, now let's see what is depletion zone. We know that we have p-type, n-type like this. And this is called PN junction. Here the crazy thing happens because in n-type there are more electrons comparing with the p-type. So slightly the n-type electrons is slightly attracted to the p-type area because there are less electrons. Because of this there will be slightly positive charge in the n-type because the electrons from the n-type slightly attracted to the p-type. This makes a slightly positive charge in the n-type, and in p-type there will be slightly negative charge. This makes a electric field between them like this. Because of this electric field there will be no freely moving charged particles in this area, and predictably this area is called depletion zone. So there is no electric flow in the diodes. But when you connect batteries to the diodes, it will allow the electricity, and that is according to a connection. If you connect the anode and cathode of the battery correctly to the diode, then it will allow. If you oppositely connected, it don't. Because when you connect the cathode to the n-type and anode to the p-type, first the electron will goes to the n-type from the cathode. The like charge will be repel and the unlike charge will be attract, right? That's a simple concept. So that's the matter is going on. So in the n-type, which has phosphorus and more electron comparing with the p-type, so an electron from the cathode also same charge, so they will start to repel. So due to this repulsion, it just breaks the depletion zone and automatically attract to the anode of the battery. But when you connect the connection oppositely, it don't, because if you connect the cathode to the p-type and anode to the n-type, because the electron which is in the n-type start to attract to the anode of the battery, and this the same matter will goes on another side, negative terminal of the battery, so there is no electric flow in the diodes. So this is a basic thing in diode, and diodes can make something really great, that when you give electricity to the diodes with correct connection, it start to emit light. That's why we are calling light emitting diodes. But in ordinary diodes, which we use mostly, you can't see the light because it is made up of silicon. So silicon only emit infrared light which we can't see. But some animals do. Okay. But when you add other semiconductors like gallium, you can see the visible light. The light which we can see. So that's why we are calling LEDs. And another thing the diode can do, and that is really great because it can produce electricity. Cool, right? So when the photons, light strikes on the silicon atom with enough energy, it can knock an electron, and that electron can move freely. But due to the electric field between the p-type and n-type, it can move in only one wave, so that it can produce electricity. And this technique is used in solar cells, solar panels. So diode is a major electronic component. It can also emit light and can also produce electricity by solar panels. And that is also non-polluting renewable energy. So that's very good. So this is why I'm saying diode is a game changer. So that's it. I'm Sunandan. You're watching KTU channel. Science is not tough, but it is tricky. Thanks for watching.